In this video, I'm going to demonstrate a quick and easy way to graph trigonometric functions. So let's start with the general form of a trigonometric function, y equals a sine of b times, in parentheses, x minus h plus k. A represents the amplitude, or another way of looking at that is a vertical stretch. B tells us the number of cycles or phases in one period, and we use B in order to find the period. H is a horizontal shift, left or right, and K is a vertical shift. We also refer to K as the midline. So let's see how we will use these particular characteristics of a trigonometric function to graph it. So in college algebra or other algebra classes, you learned to graph, and one of the first things that you do is to draw the x and the y-axis. Well, I'm not going to draw the x and the y-axis here, okay? No x-axis, no y-axis. So what I'm going to do first is, for this example, let's identify these various items. So the amplitude is 3. Our B is going to be 2, but first of all, notice that this needs to be factored. So over here, I'm going to take 2x minus 6. I'm going to factor it and get x minus 3. That is now in the correct form. B has to be completely factored out from the horizontal phase shift. This also then tells us the horizontal phase shift. H is equal to 3. Now be careful, it's not minus 3, because the formula says that it's x minus the h value. So in this case, it's x minus 3. And then of course, K is equal to 1. Now, B is equal to 2, so that means the period is going to be 2 pi divided by 2, or pi. So I'm going to draw a vertical line, and this is not the x-axis. This is my midline. And I'm going to draw a vertical line, and it is not the y-axis. So what I'm going to do is I'm going to label my midline, which is my k value. So there's 1. Now my amplitude is 3. So from there I'm going up 1, 2, 3 units. So that would be 2, 3, 4. And I'm going down 1, 2, 3 units. So that would be 0, -1, -2. So I've just used the amplitude, and I have used K in order to label this vertical line, which again is not the y-axis. Now let's label the horizontal axis. I know that my period is pi, so let's make this right at the end pi. And then let's identify the halfway point, which would be pi over 2, the quarter point, which would be pi over 4, and then this point, the 3/4 point, would be 3 pi over 4. Now, you have to understand what the general sine wave looks like. We know that it looks kind of like this. So I am going to start by saying, okay, this is going to start at right here. And then at my quarter point, it's going up to its maximum point. So we're going to have a graph that goes up like this. And then it's going to come down at the halfway point and cross the x-axis. So it's going to come down like that. At the 3/4 point, it's going to reach its minimum value, which is -2. And then it's going to come back up to pi at this point. Now you may be thinking, hey, he forgot the horizontal shift. I did not. The horizontal shift is 3. And it's 3 units to the right. So all I'm going to do is just add 3 to each of these values. That's kind of like the quick and easy way to do it. Now, if you were to graph this in Desmos, Desmos would actually give you a numerical value for pi over 4 plus 3 or pi over 2 plus 3 as a decimal value. And you can easily take pi over 4 plus 3 and find out what the decimal equivalent is of that. But this is really all you need to do to draw a quick graph of this particular sine function. You can see that it has a period of pi. It's been shifted to the right 3 places. It has an amplitude of 3. Its midline is at 1. And that's pretty much it. Let's do one more example. Now we have a cosine function. And so let's identify A. So A, remember, it's the absolute value of that -2. So it's 2. But we have to be careful because the negative is going to flip or invert our graph. Our B, we don't need to do anything to find B. This is already factored, okay? We have B, which is pi over 2, factored completely from the horizontal shift. H now is going to be -1 because x plus 1 has to be written as a minus. So that's x minus a -1. But we wouldn't write it like that. We would write it like x plus 1. K is equal to 3. And so we need to find the period. The period is going to be 2 pi divided by B, which is pi over 2, which is 2 pi over 1 times 2 over pi. The pi's cancel. We end up with 4. So we have a period of 4. So just like in the last one, I'm going to start by drawing a horizontal line, which represents my midline, and a vertical line, just so that I can label my amplitude. So the midline is 3. We are going, the amplitude is 2, so we're going to be going up 1, 2, so that's going to be 4, 5. And we're going down 2, so that's going to be 2, 1. And the period is 4, so that's going to be over here. But we have a period of 4, so that would be 4. Half of that would be 2, 1, and 3. But let's not forget that we are subtracting 1 from that. So we have the period plus the horizontal shift. So we're going to have 4 plus a -1 is 3. So this is going to be 3, 2, 1, and 0. And so this over here is -1. So we're starting at -1. All right, so remember that the cosine function looks like this. It starts high, goes down low, and comes back up again. But because of the -2, we want to invert that. So we're going to start at the low point down here at 1. We're going to come up to the midline at 0. At 1, we're going to come up to our high point. At 2, we're going to come back down to 0. And then at 3, we're going to be back down to our low point. Not a very symmetric looking cosine graph, but you get the basic idea. So let's just check to make sure that we have all the elements here. We have the midline is at 3, which checks. We have an amplitude of 2. We're going up from 3 to 5, down to 1. We inverted it because of this negative. So instead of starting at 5 and going down and then up again, we're starting at 1, going up and then back down. And then what about our period? Our period was 4, but we had to subtract 1 because of the horizontal shift. So it ended at 3. Then, so then that would be, yes, so from 2, 1, 0, -1. Okay. That is it. That is the quick and easy way for graphing these trigonometric functions. Hope this was helpful.